Hello student, welcome back. Here in this video we will go to do the solution of question number 11 of exercise 1.3. First let me read the question. Consider the function f from the finite set 1 to 3, it goes to the set ABC given by f of 1 equal to a, f of 2 is equal to b and f of 3 is equal to c. Your question is find f inverse and you have to show it that f inverse of whole inverse equal to f. Hope you understand the question. This is a finite set 1 to 3 contain 3 elements. ABC is another finite set and f is a function from this set to this set. That means the domain of the function is 1 to 3 and the codomain of the function is ABC. The function is defined like this. 1 related to A under the rule F, 2 related with B under the rule F and 3 related with C under the rule F. Your aim is to get F inverse. Now you see, if you want to find out the value of F inverse, you have to first show it that the function F is invertible. And we know when the function is invertible? Yes, when it is 1, 1 and onto. So first our aim is to show that this function f is 1, 1 and onto. Then we can easily write down the inverse of the function. First we write down what is your function. Okay, f is a function from the finite set 1 to 3, it goes to ABC and it is given by this thing. This thing is given in the question. Now we write down these things in the form of an ordered pair. 1 related with A under the rule F, so F contain 1A. And I am writing in this form so that we can write down F inverse easily just by interchanging the position of the elements. 2 related with B under the rule F, so 2B will be in the function. 3 related with C under the rule F, so 3C will be in the relation. So this is your function F. That means the function F contain 1A, 2B and 3C. Now if you draw the Venn diagram of this, if you want you can draw it. Here you see, you can draw a diagram for a closed circular form for the first set and the second one is here. Then you can write down the arrow diagram of F. 1 related with what? A, 2 with B and 3 with C. That means here we see the distinct element has distinct images because image of 1 is A, image of 2 is B, image of 3 is C. They are different elements and their images are different. And also we have seen that ABC, which is the codomain of the function, every element in the codomain has a pre-image. So we can say the function is 1, 1 and onto. That's why I am writing here f is 1, 1 and onto. And since it is f is 1, 1 and onto, it is invertible, so f inverse exists. You can use your own language to write down the solution if you want. Now if f inverse exists, then we can write down the function f inverse. How to write down this? We can see from here. If we know if f of x equal to y, then we can write down what? X equal to f inverse of y. So if f of 1 is equal to a, so we can write down what? 1 is equal to f inverse of a. That's why I'm writing here f inverse of a is equal to 1. Again, here you see f inverse of b is equal to 2 from this and f inverse of c is equal to 3. So here under the rule f inverse, A related with 1, B related with 2, 3 with C, C with 3. So you can write down f inverse. F inverse will contain the ordered pair A1, B2 and 3C. Okay. Again by drawing the same or from the same Venn diagram, we can say the distinct element is related with distinct images. Because image of A is 1, image of B is 2, image of C is equal to 3. So distinct element has distinct images. You can write down that way. Therefore, the function f inverse is what? 1, 1 and onto. And if function f inverse is 1, 1 and onto, so its inverse exists. Okay. So here I am writing f inverse is bijective. Bijective, I hope you understand. You remember bijective means 1, 1 and onto. So inverse of f inverse is also exist. And how we are going to denote the inverse of f inverse? F inverse to the power again minus 1. Right? So f inverse whole inverse, this is the inverse of f inverse. And again, f inverse whole inverse means what? Again, this you have to replace, interchange. A related with 1. When we write down the inverse, 1 related with A. So it contains 1A, Similarly, from here 2b and it will be 3c. Now, if you see this one, again I marked this as 1 and 3. From 1 and 3, you see that f and f inverse are same. So, we can write down the conclusion, f inverse of whole inverse is equal to f. Okay, hope you understand. Thank you.